Nice to meet you. I'm Yong-Jun, a PhD student of KAIST. I'll introduce my paper, Concepts and Models of Environment of Self-Adaptive Systems, a systematic literature review. This is the outline of this presentation. I'll introduce the motivation of this survey and review protocol. Then I'll provide summary of the result of this SLR and some findings. First, let's see the background and motivation of this SLR. Many studies of self-adaptive systems have been conducted. We call a system that adjusts its behavior in response to the resumption of changes in the environment and the system itself as a self-adaptive system. The self-adaptive system consistently achieves its goal, adaptive to its environmental change. Many researchers are sharing the concepts of environment of self-adaptive systems. They define the environment based on their research goal. Environment is defined as anything observable by the system, physical world or computing elements that are not under control of the system, or circumstances that interact with or affect the system by different researchers. Although the different definitions give common understanding of the environment, the concept is still implicit and ambiguous. It prevents new researchers in this academia to have concrete knowledge about the environment of SAS. To organize the implicit and ambiguous concepts of the environment of SAS, in this paper, we provide an overall landscape of current knowledge of the environment in SAS engineering through a systematic literature review. We try to figure out how various researchers commonly understand the concepts of the environment of SAS and if there are cases in which their understanding of the environment is expressed as concrete models. To have a systematic literature review, we designed this review protocol in advance. First, the research questions were defined. In the original paper, there are 6 research questions, but they have been summarized into 3 questions for this presentation. First one is to find characteristics of the environment of SAS mentioned in primary studies. Second one is to organize sources of the environmental uncertainty addressed by the existing works. The last one is to find any reference models of the environment of SAS. Based on the research questions, we searched candidate papers. We utilized 9 widely used search engines for automated search. We also manually searched all papers in 10 journals and conferences that are related to our questions. In these papers, we selected papers including these keywords as candidate papers. Among the candidate papers satisfying these criteria were selected as primary studies of this SLR. We also searched all references of the selected papers and re-evaluated the papers based on these criteria again. We repeated this process until there is no more new papers. Finally, we selected 128 primary studies from 3719 papers. From the primary studies, we selected data that can answer the research questions. To answer RQ1, we extracted every expression describing the environment. To answer RQ2, we extracted causes of the environmental uncertainty motivating the primary studies. To answer RQ3, we found primary studies that proposed explicit models of the environment and extracted details of the modeling method. Now I'll show the results of the analysis of the extracted data. This paper shows details of the analysis results, but in this presentation, I'll only present the summary of the result. First, we found and organized 5 common characteristics of environment of self-adaptive systems. First characteristic is diversity. It means that environment consists of diverse environmental factors. Environment is a set of various environmental factors. Second characteristic is externality. Environment can be only defined when the system and its boundary is clearly defined. Based on the system boundary Anything outside of the system boundary can be environment. Because they are outside of the system boundary, they also are not under direct control of the system. Third one is observability. Anything outside of the system boundary can be environment. Only observable external factors are regarded as an environmental factor. Only if system can observe the environmental factor can be target of adaptation engineering. We cannot guarantee a self-adaptive system can be adaptive to an external factor that is not observable. Fourth one is interactivity. If environment does not interact with the system or not affect the system, that doesn't need to be considered for adaptation. Environment affects decision making of self-adaptive system and its goal. And the self-adaptive system, again, affects the environment and triggers the changes of the environmental state. The last one is uncertainty. Environmental uncertainty means that the expected environmental state or knowledge of the environment differ from the reality. Therefore, environmental state at runtime cannot be fully anticipated at design time. The uncertainty is the fundamental reason of adaptation. In Arc 2, we examine the core reasons of the environmental uncertainty appears. When researchers propose their approach is to handle the environmental uncertainty, the, the environmental uncertainty has diverse meanings. Some say environmental state is fluctuating and the environment is dynamic. Others say environmental state is probabilistic or non-deterministic. Because of these reasons, the environmental state at runtime cannot be predictable. So the environment becomes uncertain. These reasons are commonly related to that engineers have limited knowledge about the environment. Therefore, we could say the limited environmental knowledge is one common source of the environmental uncertainty. On the other hand, because environment is observable and interact with the system, when sensor of the self-adaptive system has noise or sometimes fails, it causes the inaccurate awareness of the current situation. The inaccuracy can make environmental uncertainty. An actuator is also another interaction media. So if there is noise or failure, it also makes unexpected results of adaptation. It could make uncertainty. These reasons are commonly related to that the environmental interaction is not complete. Therefore, we could say the incomplete environmental interaction is another common source of the environmental uncertainty. We found the primary studies were motivated from the diverse reasons, but the uncertainty they mentioned could be categorized into these two common sources. To answer the RQ3, we found 14 models that explicitly represent the environment of self-adaptive systems. We analyzed their details, but in this presentation, only the diverse expressiveness will be explained in the following page. All of the reference models represent the 5 characteristics that we found, but their expression method was diverse. For diversity, most of the models implicitly assume that diverse factors can be modeled in the environment, but only 5 models show independent environmental factor modeling explicitly. For externality, most of the models took a strategy to decouple the environment from the system model. For observability, only 3 models explicitly express the sensor for environment observation and sensing mechanisms. The other models just assume the information in the environment model is somehow transferred to system. For interactivity, 9 models express one-way influence, which means the environment affects the system goals. However, only 5 models express that environment affects system, but also the system's adaptation again affects environment. For uncertainty, most of environment model represents the environment state varies by time. In this research question, we found diverse environment models with various purpose and expressiveness, so the collected reference can guide future works. Through this SLR, we also have learned many things not restricted to a specific research question. First one is that there is common perspectives to interpret the environment of engineering interest. First perspective focuses on the clear boundary between self-adaptive system and environment. In many cases, having a clear system boundary helps to define an environment clearly. Second perspective focuses on the interface of system-environment interaction. How environment is observed and how system affects the environment are analyzed. Third perspective focuses on environmental impact on the goal of self-adaptive system. This perspective is shown in many goal or requirement-driven methods. The last perspective focuses on the variability of environmental state. It tries to explicitly model how the environment changes by time or system. If these four perspectives are all used to analyze a self-adaptive system's environment, I believe that a comprehensive understanding of the environment can be achieved. There are some challenges and future works of environment modeling. We found almost of the existing environment modeling only considers partial environment characteristics and sources of the environmental uncertainty based on their research goal. However, to have a comprehensive expression, a future environment modeling should consider the various concepts together. In addition, most of the existing models rely on manual modeling and experts' domain knowledge. Therefore, the expressiveness of the models are relying on them. We believe more automated or data-driven environment modeling approaches are needed. In summary, we provided a concrete knowledge of the concepts of environment with 5 common characteristics, 2 common sources of the environmental uncertainty, 14 reference models, 4 common perspectives of the environmental specification, and 3 research challenges. You can find more information in our original paper and also review data in our website. Thank you for listening.